question number 86, which says that the possible set of quantum numbers for 4D z² orbital is. So we have 4D z² orbital, so means n value is equal to 4, and for d orbital the L value is equal to 2, and here it is dz orbital. So for dz the value of magnetic quantum number is equal to 0. So we have option number 2 is the correct answer. So moving on to the next one, we have question number 87, so in which we have a graph of kinetic energy of photoelectron versus the frequency of incident radiation, and we have to identify the metals X, Y and Z. So in this graph, this point represents the threshold frequency, and the lower the ionization potential of the metal, the lower will be the threshold frequency. Lower is the ionization potential, lower will be the threshold frequency. इसका मतलब क्या हुआ कि जितनी आयनाइजेशन पोटेंशियल मेटल की कम है, मींस इट इज वेरी विलिंग टू डोनेट द इलेक्ट्रॉन्स, एंड थ्रेशोल्ड फ्रीक्वेंसी इज द मिनिमम फ्रीक्वेंसी टू इजेक्ट एन इलेक्ट्रॉन फ्रॉम द मेटल. सो जितना ज्यादा उस मेटल का नेचर होगा टू डोनेट द इलेक्ट्रॉन्स, तो फ्रीक्वेंसी उसमें कम लगेगी. That is why lower is the ionization potential, lower will be the threshold frequency. So if we talk about the group 1 metals, which are lithium, sodium, potassium and rubidium. So as we move down the group, the atomic size increases, and the increase in atomic size overweighs the increase in effective nuclear charge. So as a result, ionization energy decreases. So the ionization energy decreases. So rubidium will have the lowest threshold frequency, potassium, lithium. So the option number 3 is our correct answer, and none of the other options is matching with this answer. So option number 3 is our correct answer. So moving on to the next one, now we have question number 88, which says that which of the following is not a D block element. ठीक है, अगर हम first configuration को देखते हैं, it represents a D block element, that is yttrium, and in the second option it represents the D block element, that is mercury, and in the third option it represents the electronic configuration of cerium, which is a F block element. And in the fourth one, it is the electronic configuration of tungsten, which is also a D block element. So the only correct option is our option number 3. So let's move on to the next one. Now we have question number 89, which says that the ratio of sigma and pi bonds in a given molecule is. So we have the molecule, that is naphthalene, with us. So in the case of naphthalene, we have to calculate the number of sigma and pi bonds. So pi bond, they are very clear, that are equal to 5. And we have sigma bonds that are equal to 19. You can calculate here. So the ratio of sigma and pi bonds are 19 by 5. So it is 19:5. So option number 3 is the correct answer. So moving on to the next one, now we have question number 90, which says that in which of the following ionization processes the bond order gets increased and the magnetic behavior has changed. So in the first option we have C2 converting into C2 plus. So this bond order of C2 is equal to 2, And here the electron is removed from the bonding pi molecular orbital. So the bond order will decrease. So the bond order will be 1.5. And the C2 molecule is diamagnetic in nature as no electron is paired up. So as one electron is being removed from C2, it will become paramagnetic. So here the magnetic behavior has changed, but the bond order has decreased, not increased. So this option is not our answer. Now coming to the second option, we have NO converting into NO positive. So the bond order of NO is equal to 2.5 and the bond order of NO plus is equal to 3. And here NO is paramagnetic and NO plus is diamagnetic. So here the magnetic behavior has changed and the bond order has increased. So this is our correct answer. So now we have option number 3 in which O2 is converting into O2 positive. So the bond order of O2 is equal to 2 and electron is removed from anti-bonding pi star molecular orbital. So the bond order will be 2.5. And here the O2 is paramagnetic due to the presence of 2 unpaired electrons. And as only one electron is removed, so O2 plus will also be paramagnetic because it has one unpaired electron. So here also bond order is increased, but the magnetic behavior has not changed. So this option is also incorrect option. Now coming to the fourth option in which N2 is being converted into N2 positive. So the bond order will be equal to 3. So as the electron is removed from the bonding molecular orbital, so the bond order will decrease. It is equal to 2.5 and N2 is diamagnetic and N2 plus will become paramagnetic. So now the bond order is decreased in this case and the magnetic behavior has changed. So this option is also incorrect. So the only correct option that we have found out, that is option number 2. So with this question, we end our today's discussion for AIATS test number 4 for chemistry. So I hope students you have followed and understood till now. Thank you for watching.